Alright, so here we are going to talk about Lewis diagrams and Lewis structures. So we have Lewis diagrams and Lewis structures. Really, a Lewis structure, what does it show? A Lewis diagram. A Lewis diagram shows the symbol of an atom and the valence electrons shown as dots around the symbol. For example, carbon has four valence electrons. Therefore, the Lewis diagram for that must have a symbol carbon and then the four valence electrons surrounding the carbon. Now, if you have chlorine has 7 valence electrons. So normally what I do, I will start with 1, 2, right, and then start adding the rest. So that gives chlorine 7 valence electrons. That is the Lewis diagram, Lewis dot diagram of chlorine. Oxygen has 6 valence electrons, so it must have 6 electrons. So that's a Lewis diagram for oxygen. Sodium has 1 valence electrons. That's why it is in group, because it is in group 1. So this will just be its dot diagram. Magnesium has 2 valence electrons, so you can have an electron here, you can have another electron there. So that is the dot diagram for magnesium. Phosphorus has 5 valence electrons, so you are going to have that diagram as the dot diagram of phosphorus. So really, the number of valence electrons, the number of valence electrons in Lewis diagram depends on group number. So that is group 1A to 8A. For example, Neon is in group 8A. So it's going to have 8 valence electrons. And its dot diagram will show those 8 valence electrons. So those are the dot diagrams. What about Lewis structures? So an example is, what is the Lewis structure of CH4? So we want to see how we can solve a problem like this one. So the first thing, the first way we can solve this problem is really count all the valence electrons in this molecule. So count all the valence electrons in the molecule. So carbon has 4 valence electrons, but we have 4 hydrogens here. Each hydrogen has 1 valence electron. So when you add, the total number of valence electrons will be 4 plus 4, which is 8. So that's the first thing. The first thing, count the number of valence electrons in your atom. That is the electrons in the outer shell of each atom in your molecule. The second part is you want to identify the central atom. So the central atom will be the one with the least number of atoms in the molecule. So take the one with the least number of atoms in the molecule. So in this case, it is carbon. So carbon will be our central atom. So once you get the central atom, just draw the other atoms surrounding the central atom. Now, so you need to count how many electrons has each chemical bond used. So each chemical bond in this case takes 2 electrons. So in this case, we see that count the number of electrons used in chemical bonding. Okay, let me just make a correction here. So we say when you identify the central atom connected, what you want to do is give the side atoms, in this case, e.g. hydrogen, 2 electrons each. But the electrons should be between hydrogen and carbon. So the electrons must be between carbon and hydrogen. So this is what we have done here. And then I'll just write this one again. C H H H H. So I've given hydrogen 2 electrons. Then count the number of electrons used. So if we count these ones, we see 2, 4, 6, 8. In this case, we have used all 8 electrons. Then the last part is connect each pair of bonding electrons by sticks. So here we have bonding electrons, so we are going to connect them by sticks. And then we don't write the electrons again because each stick is a pair of electrons. So this one is our Lewis structure. So that is our Lewis structure of CH4, which is methane. Alright, so let's look at another Lewis structure. So draw a Lewis structure for PF3. So the first part is we want to determine total number of valence electrons. So it depends on the group number. P has 5 valence electrons. Now we have 3 fluorine here, so 3F. So 3 times 7, because each fluorine has 7 electrons. This will be equal to 5 plus 35. So this one has 40 valence electrons. Now, after obtaining the electrons, select the central atom. In this case, the central atom is P. So we are going to have P here, and then we are going to have F, 3F surrounding P. Then give each side atom 8 electrons. That means 4 pairs. So what we are going to do is I'm going to give this side atom 8 electrons each. Making sure that there are electrons connecting between F and P, because that's where our chemical bond is. After you do that, count. So I'll put again P, F, F, F. So I'm giving these 8 electrons each. Then you count the number of electrons used. Okay, so 3 times 7. Oh, I made a mistake here. Here 3 times 7 should be 21. So 21 plus 5 is 26. So it has 26 valence electrons, not 40. So we have 26 valence electrons, and we want to see how many electrons have we used here. So this is 8, 8, 8. So 8, 8, 8, which is 24. So we have used 24 valence electrons. So how many electrons are remaining? Out of 26, 2 electrons are remaining. So where do we put the 2 electrons? Put the remaining electrons on the central atom. So here we are going to have P. We know we have F, F, F. So this one has 8 electrons. This one has 8 electrons. This one also has 8 electrons. So the remaining 2, we are going to put them here on the central atom. Then connect the bonding pairs by sticks. So we are going to have P, F, F, F. But don't forget to have the remaining 6 electrons on the F. They need to show, and the 2 electrons that we are looking for. So this one is our Lewis structure. Let's look at another structure. So what is the Lewis structure for, let me check it again. So we have C2H6. So as usual, let us count valence electrons. So we have 2C and 6H. So each C is 4 valence electrons, each H is 1 valence electron. So 8 plus 6, which is 14 valence electrons. Now we look for central atoms. In this case, we have 2 of them. Carbon is in small number, so we are going to have carbon and carbon. So each carbon is going to have 3 hydrogens. So each carbon should have the same number of hydrogens. That's what we are going to have. Then afterwards, you are going to give each hydrogen 2 electrons. So give each hydrogen 2 electrons. But the electrons must be connected to carbon. So this hydrogen, I'll give it electrons here. I'll give this one electrons here. I'll give this one electrons here. Then I'll give this one electrons. This one also 2 electrons. This one 2 electrons. And also, you need to have a chemical bond between carbon and carbon. So in this case, I'll just say I'll give these ones also 2 electrons. Then I have to count how many electrons have I used. Count number of electrons used. Here I have 2, 4, 6, 8, 10, 12, 14. So I have used 14 electrons. Then what is going to remain? I'll just connect these ones with sticks. So I'm going to have C, then H, H, H. Then another stick here, H, H, H. So that is my Lewis structure. So let me see another Lewis structure that we can draw. All right, so Lewis structure for CH4 O. So this one, count the valence electrons. So we have carbon here with 4 valence electrons, and we have 4 hydrogens with 4 times 1 valence electrons, and then we have 1 oxygen which has 6 valence electrons. So if we add 4 plus 4 plus 6, which is 14. This one has 14 valence electrons. So after that, we are looking for central atoms. So here, automatically, carbon will be a central atom. So this carbon will be surrounded by should be surrounded by 4 atoms or 4 chemical bonds. So we expect a hydrogen here. So 1 hydrogen is gone. Another hydrogen here. The second hydrogen is gone. And a third hydrogen here. The 4th chemical bond should come from oxygen, because we have 2 central atoms here. So oxygen will bond to carbon, and 1 hydrogen will bond to oxygen. That's why we have 4 hydrogens. Then give each hydrogen two electrons. Give each hydrogen 2 electrons. So here we'll give this hydrogen 2 electrons, this hydrogen 2 electrons, this hydrogen 2 electrons, this hydrogen 2 electrons. Also, make a chemical bond between C and O. And because of that, we'll give this one also 2 electrons. After that, we count how many electrons have we used, because we need to use all 14 electrons. So what have we done? We have 2, 4, 6, 8. So carbon already has an octet, so we are not worried about it. 2, 4, 6, 8. 10. We have used 10 electrons. There are 2 electrons that are remaining. So what do? We take the 2 remaining electrons and put them on the oxygen, which is another central atom in this case. Because oxygen does not have an octet yet, it needs 4 more electrons. So we are taking the remaining 2 electrons, put 1 here, another here. Then later on, connect all the chemical bonds. So we have C, H, 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 O, H, and then we make sure that we still have these 2 electrons over there. Now let me write a Lewis structure for maybe the last one or the last 2. Lewis structure for carbon dioxide. So number of valence electrons, carbon has 4, two oxygens. So two oxygen atoms have 2 times 6, which is 4 plus 12, or 16 valence electrons. Now these are the number of electrons that we need to use. Now the central atom in this case is carbon. So we are going to have carbon and then oxygen here, oxygen here. So what you want to do is give each oxygen 8 electrons. Give each O 8 electrons, because you want it to have an octet. So I'll start from here. 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. So count the number of electrons used. Here we have used all the 16 electrons. You can see here 2, 4, 6, 8, 10, 12, 14, 16. The problem is carbon does not have an octet. Carbon needs 8 electrons to fill the octet, but here it has 2, 4. So what do? You have to give it 4 more electrons so that it has an octet. So what you do is you transfer these electrons to here and put them here. You transfer also 2 here and put them here. So in the end, actually you put them here, and these ones you put them here. So I'll just make sure that that is shown. So what you are going to do in the end is you are going to have oxygen, then 1, 2, 3, 4, carbon, 1, 2, 3, 4, oxygen. Now this carbon has 8 electrons. You can see here 1, 2, 3, 4, 5, 6, 7, 8. Now because this one is gone, this part we are remaining with. So this oxygen here has 1, 2, 3, 4, 5, 6, 7, 8. This oxygen here also has 1, 2, 3, 4, 5, 6, 7, 8. The carbon here has 1, 2, 3, 4, 5, 6, 7, 8. So each molecule, each atom in this molecule has an octet. So we are fine. So the next part is to draw a chemical bond for each pair. So I'll say O, chemical bond here, chemical bond, carbon, chemical bond, O. Then so that is the Lewis structure of carbon dioxide. So really, when drawing Lewis structure, don't forget these pairs. Now, for a Lewis structure, where you have a stick here, you call these bonding pairs. These ones, you call them bonding pairs. So this molecule has 1, 2, 3, 4 bonding pairs. 1, 2, 3, and 4 non-bonding pairs. So because you'll be asked to identify which ones are bonding pairs, which ones are non-bonding pairs. So the ones that are between the two atoms are called bonding pairs because they form chemical bonds. And the ones that do not connect to the atoms are called non-bonding pairs because they do not form a chemical bond. Thank you.